Okay, I think we can start. Some colleagues are still arriving, but we're already almost 30 people. Good morning, colleagues. Welcome to the CitiObs policy workshops. In the CitiObs, we work with citizen science and community-generated data to empower citizens observatories across Europe to monitor and act on environmental challenges and promote citizens' engagement, innovative tools, and data. We show you just very briefly some housekeeping rules. Before I forget, I'm Masha Smirnova from EuroCities. I'm part of the consortium together with other partners from whom you will hear today. And we will just kindly ask you to mute your microphone.
Prima, dankjewel. Oké, prima, dank je. Dag.
Please mute your microphone during the session when we have the other presentations. You can use the chat box also to perhaps also share some resources, also ask some questions. We will take most of the questions in the discussion towards the end of the workshop. And regarding the recording, so we record this just for internal purposes because we are going to produce a policy brief that will also advance the knowledge of citizen science towards the contributions of towards air quality monitoring. And we will only make the part where we have the presentations public, but not the discussion. So we can really discuss very openly. We have also some colleagues from the member states today, including Dutch colleagues and Polish colleagues, and also regional and local authorities. So this is very nice to have such wide presence. My colleague Joao is also here. He will just switch the slides. So today we will focus on the role of citizen science and innovation in citizen science for air quality monitoring. We will particularly discuss the opportunities that citizen science also has in the context of the revised Air Quality Directive. As you know, the revised Air Quality Directive aims to strengthen air quality standards across Europe by aligning them closer with WHO guidelines. And we have some specific entry points and opportunities that we will discuss. It goes from community engagement, strengthening public information requirements, the role of complementary monitoring with low-cost sensors, and also the support to local authorities, for example, in preparing air quality plans in situations where there is where pollutants exceed the concentration levels. So because every level of government has a role to play, we try to mirror this also today in the workshop. So we will have innovations from our project participants working with the citizen science data, which we are going to present. And then we will also hear from national authorities, but also some regional authorities, for example, in Catalonia or in Aix-en-Provence, how they work with citizen science data. So without further ado, we have an expert, of course, on the revised Air Quality Directive from the European Commission with us today. I just want to have a very short icebreaker at the start of the session. If you could scan the QR codes. And the question is, what comes to your mind when you think of citizen science and air quality monitoring? What is like the first keywords that come to your mind that you would like to put forward? And then we'll do a little word cloud. We'll give it 30 seconds. And my colleague Joao is going to project the results. Okay, so we see fun. That's it's good. It's good that fun is also coming. With the engaging community should also be fun. Collaboration, empowerment, insights, data. Empowerment is coming closer to the middle ground. Listening, emancipation, interesting. Actionability. Already some challenges in the word clouds from, I think, from our scientific community. That's good. It's never too early to start with the challenges, but we will come to that later. Thanks a lot, colleagues. We'll keep it. We'll keep this slide for our further discussions, and then we can go to the introduction on the Air Quality Directive, on the revised Air Quality Directive, by our colleague Theodoros Grigoratos from the European Commission Clean Air and Urban Policy Unit. Thank you very much, Theodoros, for being with us.
Good morning, everyone, and thank you, Masa, for the invitation and the opportunity to provide an introduction to the revised Ambient Air Quality Directive. My name is Theo Grigoratos, and I work for the European Commission in the Clean Air and Urban Policy Unit at DG Environment. Slide, please. So this is a short outline of today's presentation. I will start with a short introduction of the revised Ambient Air Quality Directive, provide details on what's new in the directive, discuss a bit what we expect from the directive, and provide some concluding remarks. Slide, please. Yes, I guess most of you have already seen this slide before, or at least a similar version. So the recast directive on ambient air quality and cleaner air for forum replaces the directive 2008/50 on ambient air quality, as well as the directive 2004/107 relating to arsenic, cadmium, mercury, nickel, and polycyclic aromatic hydrocarbons in ambient air. What is important to highlight is that the member states shall transpose the new directive by the 11th of December 2026 at the latest, which is practically 2 years after the date the new directive came into force. Slide, please. Yes, this busy table summarizes the new directive in a nutshell. I'm not, of course, going to read out all elements in the table. However, I would like to highlight that the directive includes 8 different chapters incorporating 33 articles that among them they address the general provisions, assessment requirements, air quality management, air quality plans, information and reporting, delegated and implementing acts, the access to justice, and transitional provisions. Slide, please. So, going to what is new in the revised directive, first of all, starting with environment and health objectives, there is a clear target for a zero pollution objective for 2050, with intermediate air quality standards close to the World Health Organization recommendations defined for 2030, as you already mentioned before. At the same time, postponement of deadlines is possible under certain conditions. So, going to the next slide, if we try to break this down in more detail, this slide presents the various annual air quality standards by comparing the current values, which will be valid until 2030, and they are depicted here in dark blue, with the values of the new directive that will come into effect post-2030, which are depicted in blue, and with the recommended values by the World Health Organization, which are depicted here in light blue. I'm not going to read all this one by one, but I think that this is of added value to have this slide here, which will stay with the group later as a reference, so everybody can really have a look and see what are the current status and the future status. Going to the next slide, we have a similar setting here. This slide summarizes the various short-term air quality standards, not the annual. Again, comparing the current values with the values in the revised directive and with those recommended by the World Health Organization, again, using similar color coding, only here having added in this pinkish or purple color than maximum number of days that certain standards can be exceeded. Going to the next slide, we come to a quite important aspect where in a given zone, conformity with the limit values for PM10, PM2.5, NO2, benzene, or benzoapyrene cannot be achieved by 2030, member states may postpone that deadline for that particular zone, provided that specific conditions are met. This postponement may be up to the 1st of January 2040 or up to 1st of January 2035, depending on specific conditions that are already described quite well in the directive. In order to postpone and attain a deadline, member states need to establish an air quality roadmap by the end of 2028. I will come back to this later, for the zone in question, and they should also demonstrate how exceedance periods will be kept as short as possible. Next slide, please. So another novelty now in the revised directive relates to governance and enforcement objectives. Here we have provisions enabling a regular review mechanism. We have novelties related to air quality plans and air quality roadmaps. We have improved enforceability in Articles 27, 28, and 29, and there are also provisions related on more transboundary cooperation. Slide, please. Today I will focus more on air quality plans and roadmaps. So this slide here attempts to summarize the key differences between these two. So on one hand, air quality plans are needed when there is an exceedance of a limit or target value after the attainment deadline, or if the average exposure reduction obligation is not attained. The objective of air quality plans is to keep the exceedance period as short as possible. On the other hand, when we talk about air quality maps, which of course are themselves air quality plans, these are required when there is an exceedance of 2030 limit or target values in the period from 2026 to 2029, and the objective is to attain the limit or target values by the attainment deadline. Going to the next slide, and I'm really sorry about the colors here. It was not intended to be like this, so I will submit a different version maybe to Mass after the meeting, so to keep the slides and not have these gray colors here that are not readable. Anyway, this slide tries to summarize the timeline applicable to air quality plans and roadmaps. In the interest of time, I will not go through the slide in detail. However, again, I believe it is useful to have this slide as reference for those who will access the slides after the meeting and would like to see what are the main differences between plans and roadmaps. Before switching to the next note, however, I would like to point out that the air quality plans is one of the topics in the directive that require community engagement. More specifically, Article 19, paragraph 7 stipulates that member states shall encourage the active involvement of all interested parties in the preparation, implementation, and update of air quality plans. So for us, this is quite important to mention here. Next slide, please. On monitoring and assessment, the most important novelties relate to the enhancement of the role of modeling in air quality assessment, the study of the representativeness of the sampling points to better inform the monitoring network, and the monitoring of pollutants of emerging concerns. So we mentioned here ultrafine particles, black carbon, and ammonia. Slide, please. So looking in more detail into the role of modeling in the new directive, this can be split into 5 thematic categories. So firstly, modeling has a prominent role in informing air quality assessment and informing the spatial distribution of air pollutants. Then modeling becomes important in informing the spatial representativeness of sampling points and the network design. There will be an implementing act on these 2 topics. In forecasting, modeling offers short-term projections of air quality pollution peaks. In source apportionment, where modeling provides support in assessing links between emission sources and air quality. And finally, in air quality planning, by quantifying the expected impact of measures. Slide, please. Yes, on the monitoring of pollutants of emerging concern, the introduction of monitoring super sites has been mandated in the revised directive. So these are monitoring stations at urban background and rural background locations with multiple sampling points to gather long-term data on several pollutants. including those of emerging concerns such as ultrafine particles, black carbon, and ammonia. What is quite important to mention here is that for ultrafine particles, at least one sampling point per 5 million inhabitants will have to be established at the location where high concentrations are likely to occur. And again, before going to the next novelty, I would like to mention here that when we talk about modeling and the special representative sampling point, the network design, this is again where we see involvement of complementary measures that could provide valuable information when designing the network and informing the special representativeness of sampling points. Going to the next slide, last element related to the novelties in the revised directive relates to information and communication objectives. Here we have more up-to-date air quality information aiming to reach the public, and along with information concerning possible health impacts and recommendations that we would like to increase the way this reaches the public. Slide, please. On this novelty in general, I will not say too much. However, I would like to make a reference to the Air Quality Index, which is a mobile application available for download, prepared by the European Environmental Agency. This app provides real-time info on how clean is the air where we are, and how does the air in our city compare with what is the status of the air in other cities or regions. So I would like to invite you, in case you haven't done so, to download the app. There is the link down there in the bottom of the slide, and explore the functionality of the Air Quality Index. Slide, please. So yes, what is there to expect from the implementation of the revised directive and the novelties introduced? Well, first of all, we clearly discussed the health benefits with a target to reduce the number of premature deaths linked to air pollution by 50% more than without the application of the policy. Then we have the social benefits, since strict limit values protect mainly sensitive populations and vulnerable groups. There are clear environmental benefits with anticipated decreases in eutrophication and acidification of ecosystems, as well as with less crop losses and damage to forest. And last but not least, there are expected economic benefits, with annual total gross benefits predicted to be close to 42 billion in 2030. Slide, please. And this is the end of my presentation. In a few bullet points, I would like to start with a remark that for sure the EU clean air policy works. We have seen major improvements in air quality since the 90s. Air monitoring and air quality modeling provide us with a robust, comparable, and harmonized information basis across the EU. Implementation, governance, and communication will be key to get the most out of the EU clean air policy. Of course, we understand that some regions in the EU will face more of a challenge to reach future air quality standards, but many of these regions have been striking improvements in recent years. And finally, the revised directive will bring significant health, social, environmental, and economic benefits across the EU. So thank you very much for your attention. Apologies for going slightly longer than I expected, and please feel free to contact the Ambient Air Quality team through our functional mailbox, which is depicted in the next slide. So thank you very much.
Thank you very much, Theodoros, for sketching the highlights of the revised air quality directive in such a condensed time. You already mentioned the role of the European Environmental Agency in collecting and validating the data that also is coming from member states, and of course the important role EA has in the science policy interface and supporting the policy developments. So I would like to hand over to Alberto González Ortiz from the European Environment Agency, who will give us a snapshot from the air quality status report from 2025, and also tell us a few elements about the role of EA's work on citizen science and urban air quality. Thanks, Alberto.
Thank you, Masha. for the introduction, and thank you also for the invitation to take part in this workshop. As you see here, my main focus of the presentation will be the results of the Air Quality Status 2025. It's a report that was published last month, but no, two or 3 months ago. And it will be a nice complement to the presentation done by Theo. If we go to the next slide, please. So here you have an outline. As I said, I will focus mainly on the status report, but since we are in this workshop and you work with cities and you work on citizen science, I also wanted to give a brief highlight of the work that the agency does in terms of urban air quality and our previous work on citizen science. Next, please. So coming back to the air quality status report, this is an annual publication that is based on the official air quality data reported to the agency in the context of the directives that were presented before by Theo. And is also supported by 2 additional reports that we do together with our European Topic Center, when you can find additional information. Next. But the main results, or what the report focus on, is in analyzing the status of air quality with the latest available data. So we used validated data, in case validated data from 2023, and the data provided on a near real-time basis during 2024. So we analyzed the situation of both years under the current EU standards that are the ones defined in the old directives 2004 and 2008, also against the guideline levels defined by the World Health Organization. As a novelty this year, we also analyzed the situation already in 2023 against the standards that will be in place in 2030, following the adoption of the revised directive. Of course, this is kind of a previous analysis, trying to understand how far we are from these new targets, these new standards, assuming that the situation will continue to improve up to that day, 2030. Next slide, please. So we analyzed all the pollutants regulated in the directives, but for the sake of time, I will just focus on one, PM2.5. Here you have the 2 maps with the situation of the annual concentrations in 2023 to the left, 2024 to the right. So the first thing you can maybe notice is that in 2024 we haven't noticed so many stations as in 2023. This is because, as I said, the 2024 situation is based on the data reported on near real time, and not all countries report data on this near real time via. But what we can see is that each point represents a monitoring station, and the colors indicate, according to the legend, the situation. So we have as red dots those stations with values above the annual limit value of 25. The dark blue points indicate stations with value below the World Health Organization air quality level. If you go to the next, please. And this is sorry, this is a summary of the situation. So we see similar results in both years. It's true that the situation doesn't change that much from one year to another. So we see around 1% of stations with values above the current annual limit value of 25 micrograms per cubic meter. Around 90% of stations are a bit more with values above the annual guideline defined by the World Health Organization. So in that sense, we can see how far the current standards are from the World Health Organization. Next slide. In connection with the PM2.5, I present here the situation of the average exposure indicator, which is a measure, a concentration of PM2.5 based on a selection of urban background monitoring stations done by the countries. So the average exposure indicator is the 3 years average at a national level of the measurements in these stations. And there are two obligations linked to this average exposure indicator. What you see here is the whole bar, let's say up to the end of the orange bar, is the situation back in 2010 or 2011. The vertical line at 20 is the exposure concentration obligation that has to be reached in 2015. And the blue part of the bar is the situation back in 2023. So we can see that all the values in 2023 were below 20, indicating that the exposure concentration obligation has been reached. And also, you can see as triangles the national exposure reduction target, which is an objective to be reached in 2020, and is a percentage of the initial concentration. And we can also see that all the blue bars in the graphs are to the left of these triangles, indicating that in all cases, this national exposure reduction target was reached. And actually, the minimum reduction has been of 17%, and in 6 countries, the average exposure indicator has more than halved in relation to the initial one. I present this because this is an indication of how the situation has improved in terms of fine particles at urban level. But of course, you can also see that in most cases, we are far from 5, which is the recommended by the World Health Organization. Next slide, please. So here I will present the situation, the novelty I was announcing at the beginning of the presentation. How was the situation in 2023 in relation to the 2030 annual limit value? I will focus again on PM2.5. So in the map, again, you see the colored dots for each monitoring station. In this case, the legends are a bit different to the maps presented in the previous slides. So what you can see here is for the blue dots, both light and dark blue values below the new limit value of 10 micrograms per cubic meter. And then you have for the yellow color stations with concentrations up to 25% above this 2030 limit value. For the orange, between 25 and 50% above the 2030 limit value, and for the red, above this 55% of the 2030 limit value. Next, please. So here you also have per country a summary with all the range of concentrations, and you can see that already 7 member states and 4 other reporting countries had in 2023 all their stations with values below the 2030 limit value. Next slide. We also did the analysis for the daily limit value. This is a new standard, and it's set at 25. And again, the color codes in the map represent the blue values below the daily limit value, and then for the other 3 values above these percentages of the daily limit value. What we can see here is that, of course, I mean, the areas with highest concentrations are coincident, but we see fewer red and yellow dots, indicating that it seems that more stations are already in compliance with the daily limit value than for the annual limit value. Next slide, please. And here you have a summary for the new annual limit values for the main pollutants. So, for instance, for PM2.5, we see that in 2023, 8% of the stations had values below the World Health Organization guideline level. 59% had values below the 2030 limit value, and 99% had already values below the current annual limit value of 25. And you can see that for all the pollutants, you can see like this kind of progression, so almost full attainment of the current limit values. In some cases, like ozone and PM 2.5, far away from the recommendations by the World Health Organization, and then in the middle, the situation in terms of the 2030 limit values or target value in the case of ozone. Next slide, please. And here you have a summary. So if you click again, we can see that for PM 2.5, as I was saying, we already have 59% of stations with values below the annual limit value and 69% below the daily limit value, indicating that it seems that with the new standards, the annual standards are stricter than the short-term ones, contrary to what is the situation, for instance, now regarding PM10, where the daily limit value is stricter than the annual limit value. If we click again, we see that the situation is even more clear for NO2 when we see 70% of stations in 2023 already with values below the NO2 annual limit value in 2030 and 91% below the values of the daily limit value. And if we click again, we also see that for PM 2.5, we find the highest distance to target, as we have around 15% of stations with values above, exceeding 50% of the 2030 limit value. Next, please. So as I said, just a brief indication of the work we do when it comes to urban air quality. Here you have 3 graphs. The one up to the left is it comes from the indicator measuring the exposure of urban population to certain concentrations above either the current EU standards or the World Health Organization guidelines. And here again, you see how different these values are. We have almost all population living in areas where the limit values or the target values are reached, while we still have more than 90% of the urban population living in areas with concentrations above the recommendations by the World Health Organization. To the left low, you have the city viewer when we provide information on at city level of the concentration in the last 2 years, and you can compare different cities among themselves. If you look at the map, you can see that the highest values, that means the worst air quality, happens in the east, and this is coincident with what we were watching in the maps at the station level. But this viewer will be updated this year to include also NO2 and ozone, and then the picture will be slightly different because we will consider the situation in relation to these 3 pollutants. And then in the middle, you see our air quality statistics viewer when we provide information at city level, at station level, but this has several functionalities, and you can select a specific number of stations, and you can see the evolution along time at national, city, and station level. And if we click again, I would also like to mention the European Air Quality Index. They talked about it. Just to indicate, as he said, that this is a joint effort of the Commission and the European Environment Agency. We have a webpage. We have also a downloadable app, and you can check the situation at station level and also in a map layer where you find information for every single point in Europe. And this also will be updated later this month to take into consideration the World Health Organization 2021 guideline levels. And if you go to the next slide, I present here some work that I was by the agency in terms of citizen science. I would say these are a bit old, so the latest report are from 2020. To the left, you see a briefing, a report, kind of leaflet, when we analyze in 2029 the situation in terms of citizen science. So we provided some examples. We analyzed how the low-cost sensors work at that time, and I say at that time because, of course, the technology has evolved a lot. And we also, at that time, at least the main issue was the reliability and how to quality check from the low-cost sensors. And also, one of the main conclusions is that having an isolated sensor didn't work that much, that the main issue was to have networks of sensors if we really wanted to have reliable and meaningful results. In the middle, you see the Clean School. That was a citizen science project coordinated by the European Environment Agency in cooperation with the European Protection Agencies Network. And in these cases, in participating countries, some schools were selected. And then in these cases, the campaign was focusing on NO2 with samples at the entrance of the school, somewhere in the school, like a backyard, also exposed to emissions of the road traffic. And in this case, the main issue was to raise awareness among teachers, parents, and students on how on the effects of air pollution, and also how, for instance, bringing your kids to the school by car could influence the exposure of the rest of the children. And finally, to the right, you have a report that we produced together with our European Topic Center, analyzing how the public awareness had helped to improve air quality. And in this case, we also analyzed some case studies of citizen science, and we also analyzed how the influence of the environmental NGOs through public awareness, but also through court cases, has helped to improve air quality. And this leads me to the last slide with some conclusions. So EEA is the main air quality data hub in Europe due to the fact that we collect air quality monitoring and modeling data under the framework of the Air Quality Directive. We offer several air quality services based on this collected data. And as was pointed in the previous presentation, we will be a key player in the Revised Air Quality Directive through the continuation of the data collection, contributing to the directive regular review with this important tool, which is the European Air Quality Index, and of course, assisting our member countries to implement the different provisions in the directive. If we come back to the web status, and it was also pointed out by Theo, we see a continuous improvement of air quality in the last years, but we see that there are some concentrations still above the current EU standards that in some cases are in place since 2005, and that the situation is much worse if we compare to the World Health Organization guideline levels. But if we look also at the 2013 EU standards, we see that a significant proportion of stations have already concentrations below these standards, especially the case for carbon monoxide, benzene, and SO2. And what I highlighted also before, that the distance to target is bigger for the annual standards than for the short-term standards. And with this, sorry if I was a bit longer, but I thought that there were very valuable information I wanted to share with you. And in the next slide, you also have my email address. You can contact us for whatever doubt, need of data, or any additional information on our services. Thanks a lot.
Thank you very much, Alberto. Thanks also for mentioning the valuable EA resources. Indeed, the policy brief on citizen science from 2020, we use a little bit as our baseline, where it makes some predictions in the future on sensor improvement, community engagement. So with CitiObs, we are also trying to showcase some of the progress that has been made since then, and we also hope to inspire perhaps a future edition of the EA policy brief on the role of citizen science and air quality monitoring. And with these words, I would like to give the word to Nuria, our scientific coordinator, who will synthesize a bit the information, introduce CitiObs, and speak about the role of citizens-generated data in air quality monitoring. Over to you, Nuria.
Thank you, Masha. So I will try to say like why we believe that CitiObs is we needed a project like CitiObs. So next slide. So we have seen from the presentations from Theo and Alberto that Europe is fighting air pollution, and fighting air pollution that needs a collective effort. It's not the effort only of authorities, but also the effort of all the citizens. Okay, next slide. The current situation we are facing is that directive demands data. We know that although we have a huge monitoring network with reference, we are still having gaps in our observations at city level and also at rural level. So citizen-generated data can complement the official monitoring. But it's not only about data, it's also the fact that plus an action, because it builds public trust in the quality they received, and that can translate in an understanding and also an active support, a change of behavior, and a more trust in the necessary air quality plans that to keep going down in the air pollution. And also by engaging citizens in citizen observatories, we can also drive this urgent change, because we need healthier cities, not in 20 years, but we need them right now. Next slide. We are contributing to this from the project, generated for harmonizing and validating citizen collected data or sensor data in general, that can work at European level. This validation algorithm is agnostic to sensors. It works with any type of sensor from different manufacturers, including from do-it-yourself sensors and sensor.com community to other more advanced sensors or manufactured mid-cost sensors deployed by companies and used in smart cities. So we have tested and validated this algorithm, and we can see that it truly improves the bias and also the correlation of the data. Next slide, please. And we have now also tested how then we can integrate this validated data from this algorithm into official models like the CAMS model. And then we have tested this. I will not go in the details, but we have tested this, and what you can see in the picture, the colorful picture at the bottom, it's a screenshot from Poland, in the areas of Krakow and also Warsaw. And you can see on the left is the CAM reanalysis at 10-kilometer resolution. That's produced every day, and then we have also what this down scaling we do with low-cost sensors and reference stations too. And you can see that we can work at 1 kilometer, and especially in the areas where we have dense sensor networks, we can really improve the granularity of information. So this is really like some of the things that we can offer, not only at city level, but at European level. Next slide, please. And again, as I say, it's not only about data, that is actually very important, but it's also about inclusivity, trust, and social action. So we believe like and the citizen observatories, it includes from the schools, and I think Alberto also mentioned, creating young generations that are really understanding everything. But also, like you see, like a more adult population installing even reference monitors in their gardens to validate the sensors, and also the picture more on the right, like this is in Barcelona, like a group of people getting together to plan actions in their neighborhood to create awareness in more engaging ways. Next slide, please. So in the CitiObs, besides all the technological advancements and for validating the data and the data of existing observatory systems, we are also creating this knowledge platform. That's it's an open platform, it's a collaborative platform, and it will hopefully give to many citizen science initiatives and citizen observatories, the existing ones and new ones to come, a place where they can learn from the lessons from other observatories and enhance their observatories to be more inclusive and also to validate the data and with that create strong observatories that are long-lasting in Europe and can contribute with their data to the new Air Quality Directive. Yes, next slide, please. So in CitiObs, we started working with some front-runner cases, and you will hear from some of them, as Rotterdam and Kristiansand today. But also we have now engaged with alliance cases, and you will also hear from them from Atmosud, and also in the next phase, we will still work with new 50 fellow cases in Europe. So at the end, we will test this methodology that we are creating with 85 cases and hopefully even more by the end of the project. Next slide, please. So just a little summary, we believe from the project that citizen science can truly support the directive on ambient air quality and cleaner air for Europe with air quality data, public awareness, and also actions. And we can integrate validated citizen-generated data and foster inclusive public engagement. Thank you very much. I think that's my last slide. If you can just click.
Yeah.
And yeah, this is my email and also the one from the project and all the network of partners that are contributing to this good work. Thank you very much, Michelle.
Thank you very much, Nuria. I hope you also feel inspired now and it has awakened curiosity of using citizens generated data. Perhaps you're already working with communities in your local context, and I think we have a little Mentimeter, Joao, right? Yes. So a second warm-up question. Do you already work with citizen science data in your work? You have several options. Perhaps you are not working with citizen science data yet, but you are planning to. So please click on the option that is closest to your current activities, and don't be shy. Of course, everything's completely anonymous. It's just to feel the temperature of the group. Yeah, we have a citizen science enthusiastic audience with us today, of course. So there is already a large majority, a little bit more equalized. Yeah. Well, we can say that the large majority is already working with citizen science data either regularly or occasionally. And some of our participants are not working with citizen science data yet, but planning to. So I think it's already quite an enthusiastic indicator that citizen science is also enjoys popularity across Europe, and indeed communities are working with their respective local and regional authorities on improving air quality in the respective cities and localities. Thank you very much. We'll take it as positive. And now we will present you some of the short use cases that we have from our front-runner and alliance cases that Nuria just mentioned. And you will see how it connects with the key entry point that were also mentioned at the beginning. recalling what Alberto said about the reliability of sensor data, the network of sensors, vulnerable hotspots such as schools and hospitals. We will also come to that. And then we will also speak a little bit about the role of industrial pollution, because as we know, of course, we have now a clean industrial deal, not just the Green Deal, but a clean Green Deal that is supposed also to promote clean technologies. But of course, we hope that it will not come to the detriment of vulnerable community and air pollution. So we will present you some use cases across Europe. First, I would like to invite Dominique Robin, who is director at Atmosud, which is the regional monitoring agency of Provence-Alpes-Côte d'Azur region, one of the most beautiful regions of France, that boasts, of course, quite a few very major cities such as Marseille, Toulon, Nice, Avignon. And with Dominique will also be accompanied in the end by our consortium partner colleague, David Rion from Air Sentinel. And I will give the floor over to you, Dominique.
Thank you, Masha. Good morning, everyone. First of all, I want to very thanks CitiObs for this invitation to share and to give the opportunity to give our experience in south of France. Next slide, please. Well, my name is Dominique Robin. I will give you my email. As you said, I'm director of Atmosud, which is air quality survey in south of France. My specialty is chemist, and mainly photochemistry, because we have a lot of ozone and ultrafine particulate in the south too. And I am head of digital innovation in France for Atmo France, which gather all the organization in this different region in France. Our mission is quite simple. We survey air quality. We have four tools. It's classical reference instruments, yes, emission cadastre, modeling, and we forecast air quality. And I will deal with the question of sensor in the survey now. And what we could say, it's different than 10 years before, because Alberto says the technology has evolved a lot yet. It's true. We could use it for survey and not just for sensibilization, as we saw before. Please, next. Well, we have developed our own technology in open source solution. We could use it and to develop and share with us all your new ideas for have a chain, a metrodic chain consistent, and for mobility, a fixed station, indoor, because air quality is not just a top-down approach. We need to have a local and classroom. We said before, air quality around school is important, but inside it's even important. And we think that's for a health approach, we need to have a continuum information. Next, please. We monitor air quality with reference. Okay, it's a basic activity, and our challenge was to give good information and a trustable information with sensors and a reliable. And we make two corrections for that, and I will give you some results. The first one is to qualify each sensor, because we as we can see on the slide before, we will see that we have different responses in the same technology. We tested two microsensors for PM, next PM for Terra and Purple Air. Now we work with French solutions, that's Terra sensor, and the protocols to compare the reference with the sensors during 12 days. Okay, we have analyzed, and we could exclude or include the sensor, because sometimes we have problem like for reference, it's the same problem. Sometimes there is technical problem. Okay, we exclude them, but this comparison is used to make a correction with linear or polynomial. We'll see that with a simple mathematical function. Okay, next, please. For example, on the left, on the right, sorry, you have two examples of response, and you have on the base reference station and the sensor. And as you can see, the mediator line is ideal. And for the first one, we have a linear response, and for the second one, it's not linear. And we have to correct this information from the same technology. The first step is correct and standardize the information, but as you know, I think so, we have a second problem, that's the environment, the humidity, the particulate nature will influence the information and the data. And for that, we put second correction in real time, not just in a laboratory on a source compare. We need to have real-time information, and we have a couple of information with reference and the sensor in a station. On the top here, we have the station and the sensor, and we have online correction for correcting the bias between the reference and the sensor. Next one, please. And finally, we have very, very good results because, for example, from PM 2.5, it's not just an example. It's really 1 year tested with many of sensors. We have results for our daily and annual information for PM 2.5. As you can see on the right here, the gray is raw information and the blue is a correction with the two correction. And the result is here for expanded uncertainties for only, for example, for 40 microgram cube meter, it's 26% of uncertainty. And in the bottom here for annual one, it's 4%. 10 microgram cube meter, mean in France, as we saw before, it's plus or minus 0.5 microgram cube meter. It's very, very good, and you could use it sensor now for sensibilization. But if you process and treat the information, you could use it for survey and to give information for local information and action local, because we think that air quality is not a top-down approach, as I said before. Please, the next. In summary, you have the chain, raw data, quality control with the first correction, the second correction, and after we use it, we have developed our own website and share user, because we use it for participatory and citizen observatory now. It's non-profit organization, local information, and to engage, as you said before, all people, because we found we have to give sense now for air quality, because in France, as you see, perhaps emission zones are rejected by the government, and we know that air quality has to be local for the population and linked to the health in general. Please, the last one. And here, our experience of modelization, we produce every day 25 meter resolution information in constant, but even in a project, in forecast. And we need to have more information, more observation. And we assimilate the data of the sensors to give the local information and to integrate events coming locally. We think that providing a trusted information is linked to local actions that give meaning, and it's a line we follow. I hope we will continue to work together. Thank you for your attention.
Thank you very much, Dominique. David, are you here with us, David?
Yeah.
Perfect. I'll let you conclude.
Yeah, just go on the final slide. Thank you. So thanks a lot, Dominique, because we've been working together for quite a long time, and it's always interesting to see how a local air quality association can do so much and evolve and catch up with the new technology. And that's one of the new technology we've been talking a lot about, what sensors can do and cannot do. For a long time, we had to provide huge amount of correction on low-cost sensor, which is a terrible world. Low-cost sensors means it's just providing, I think, a bad idea of what those things can do at the moment. But anyway, so improving the technology now can help bypass all the problems, most of the problems we used to have. So at the moment, we can have much more reliable data out of the sensor. So that's an example. That's called XPM. And there's a huge problem with humidity when we are measuring PM with local sensors. And those technology now can help heat up the air like reference instruments do. So it's been miniaturized, integrated directly in the sensor. It's still not perfect. But still we're getting there. It's getting better and better. And for something that's below 100 euros, we can really start having technology out there that makes a difference. And if on the next, please, and that's the kind of technology that now is being recognized at an international level. For example, this is the class 1 certification in Korea that mentions that those kind of technology can be used for reference monitoring on PM. So I think that's quite interesting. It's a great challenge, but it's very exciting at the same time to see that new technology and new methodologies can provide the trust and reliability we need to integrate those local sensor data into the mainstream. Thank you.
Thank you very much to both of you. I think it was highly interesting also to show the technical progress on the sensors and the validation and reducing the uncertainty. We take the recommendations of not using local sensors. Maybe we can say affordable sensors or accessible sensors. So I think it's a good point. There will certainly be some questions. I hope you both can stay with us for a bit longer. And I will give the word over to Hester for our frontend from Rotterdam of integrating local sensor citizens collected data into national air quality monitoring system. Over to you, Hester.
Yes, thank you very much. I'm quite thrilled to be talking about Rotterdam because Rotterdam is a very special city, and their project with air quality monitoring was really one of a kind. But I'm not from Rotterdam. I'm from the National Institute for Public Health and the Environment, and so I would like to tell you a little bit how the project of Rotterdam fits into a larger infrastructure in the Netherlands for air quality, and I hope this is inspiring for us to scale it up, perhaps even further to a European scale. So this is what my national help, also regional and local governments. So if you go to the next, I'll tell you a little bit about the national scale, which we've and this started around 10 years ago when it was noted that a lot of air quality monitoring sensors were invented and people started using them. And so the ministry asked us, hey, can you tell us, you are the institute that does the official air quality monitoring, can you tell us something about what we should think of these sensors? And so we were about it and we put it on the website and we started these projects to see what was going on in this field. And one of the things that happened is that people asked us, look, you're from the official institute. Are you interested in my data? I have all this beautiful sensor data. Are you interested in it? And the thing that was revolutionary for us was to say, no, we don't want your data. We are the official measurement institute. Our data is perfect as it is. Thank you very much. Instead, we said, yeah, why not? Let's bring it on. You're interested in air quality. For us, that is very important subject. It's very impactful on health. So let's bring it on, share the data with us, and that resulted in the map you see on the right here. And we are now we have been growing since 2006 when we started, from 70 to 150 to 300 to currently 3,000 air quality sensors, 4 billion measurements, and there are now more than 40 initiatives that are using this infrastructure. So the dots you see here are the places where people have sensors, and they are not our sensors. They are sensors from people in the country, and from several initiatives that have set up their own local networks. And I should give a shout out to Sensor Community, because that's the formerly was called data. So one of the reasons that we could grow so fast was because we could also say to people, hey, if you use the method of Sensor Community, that is already there, and it's for us very easy if you just connect to them. And so a lot of these sensors are actually using the Sensor Community method. But one of the big initiatives that came up was using a different sensor, and that was the city of Rotterdam. So if you go to the next slide, you can see here, this is called the Luchtclub, so the Air Quality Club Rotterdam. It was an initiative by the local government, so the city of Rotterdam. They decided, okay, let's have several, actually they aimed for 1,000 and they came pretty close, but roughly 300 of these sensors have been in the air for a long period of time. You can see here, Rotterdam is the biggest harbor of Europe. And so there are air quality issues there. And you can see the blue dots are the places where we have official measurement stations, because the local EPI has a lot of local, so that is DCMR. They are the local EPA, and they're very active, and they have a lot of measurement stations there. But you can see that the yellow dots are still having an impressive coverage, which adds data to this whole system. And our data analysts are still working on this data, because this is a huge, I mean, this is roughly, well, it's more than 10% of the measurement infrastructure that we have in the Netherlands. So for the sensor data, so it's a very huge chunk of data, which produces lots of beautiful insights, and I cannot tell everything. So, but let's highlight a couple of things. So if you go to the next slide, you can see the area of the harbor and of the city of Rotterdam, and you can see how many on the left you can see the official measurement stations, and on the right you can see the huge amount of data collected by citizens. So if you go to the next one, we can have a look at the data. Well, you saw already in the past presentation that you can have a look at. I mean, the first thing we did as an official institute for air quality is have a look at the quality of the data. Because if you have so many sensors in one region, that is really something that becomes possible. Like in the last presentation, we looked at the quality of the data, because that is also one of the first things people ask us: how well is my sensor performing? And as in the last presentation and in the presentation before from Alberto, one sensor is no sensor. So if you have a lot of sensors, we are called measure together, and that's not for nothing. One sensor is no sensor, but if you have a whole network of sensors, you can really see that the quality of the network of sensors is really quite high. So here you can see some pictures. I will not talk too much about it because it was already shown before in the previous presentation, that the quality of these sensors can be quite. And also, since we have these facial measurement stations also in the neighborhood, we can also do a correction and make the data quality even higher. So, but still, look at the data. This is looking from a perspective of the official data, and you can see that the data is pretty high quality, but it becomes more and more interesting if you start looking at what the data can give you for extra information. So as I said, our data analysts and the data analysts of the local EPA are still working on this data, but I want to highlight one more thing, because this is really working with these sensors is innovation. And these sensors are not the same as an official measurement station in the same way that wood and plastic are not the same. You can make a wooden spoon and a plastic spoon to stir the soup, but there's so much more you can do with plastic than just making replica wooden spoons. So if you go to the next slide, I want to highlight something that we are now looking into, and that is that with these sensors you can give hyper-local, you have hyper-local information. So it's like peeling the layers of an onion. You can tackle air quality problem, and you end up every time with a new problem. So if you make the factories cleaner, if you make the cars cleaner, the air quality will improve. But at some point, you have to look for the newer problems. And one of the things in the Netherlands that we see is that wood burning is becoming one of the problems, and that is a hyper-local problem. And these sensors are perfect at looking at this hyper. And we are still learning how to do that. It's really tough, but you can see, and this is one of the things that the people that own these sensors ask of us: please give us not the hourly values as we normally do, because that's also what the official measurement stations do, but give us the minute values, because we want to see the peaks that are very short and very high, and that give us the information about the wood burning of the neighbors or the barbecue. And in this, and what we also see is that if you start looking at these hyper-local measurements, then you also need the context from the neighborhood. You need to know, is it the people having a party with barbecues in the street, or is it something else? And that you don't know if you're looking from one central point in the national. We are located in the middle of the country, and this is really information that the people only have in Rotterdam. So that is the added value of citizen science. You're really doing it together. So I think we're now going to the last slide. Yeah, so if I would sum up the lessons we learned, is like, okay, we built this national infrastructure, and people, it makes it very easy for people to start a local citizen science project. So the city of Rotterdam makes use of this measure together infrastructure, and that made it possible for them to set up a really huge citizen science project with hundreds of sensors in a very efficient way. And for us, it also means that this data becomes unified. People start using similar sensors if they see it works well in another project. So without us telling people what to do, they still start doing similar things. They are in contact. So, and one of the reasons they come to us is because we are the official air quality. So the question, what is my sensor, which is a primary question people have, that is really something for us that we can answer. So we set up this project by really listening to what people needed, and we are still doing that, and we are still learning. And it would be great if this approach could also be scaled up. So that is where I want to stop.
Thank you very much, Esther, and also for connecting the data, to the more societal aspects. This was very interesting also to see how the qualitative and the quantitative aspects are so closely intertwined. We will also come back to the example later. I think it's a very nice use case that inspires also hopefully higher levels of governments to adopt similar practices. Our last use case is from the Norwegian city of Kristiansand, and we will look more to community engagement, industrial pollution, and hotspots. I'll give the word over to Solveig from the municipality, and also Julia will complement the presentation.
Thank you, Masha. So I will start myself, and then Solveig will finish with the remarks. Yeah, so you can go. So there has been an ongoing collaboration between the Kristiansand municipality and NILU Main Institute since 2019 in the use of sensors when it was still like very in the beginning, and so we started by testing sensors and see how the sensors can complement the official monitoring, and also trying to have a network that could give support to municipalities interested in using this technology at the local and at the national level. And we, I think, immediately saw the opportunity to engage citizens in this monitoring, and we are level, also now CitiObs and More for Nature at the European level. Next one. Some of the things we have tried with the municipality is investigating residential wood burning in some of the areas that the municipality tell us that they suspect concentrations might be higher, and there is no reference monitor nearby. So in this, we used static sensors that residents mounted in their houses, but also mobile sensors that they had on their bikes. With the static sensors, we were able to already pinpoint some of the areas with higher levels of PM2.5, mostly due to wood burning, and then we could assimilate this data to the national air quality model, and we could see that the local data gathered by residents improved the outcomes of the model. But also, by using these mobile sensors mounted on bikes, we could see what you have here. Like if you in the one on the left is one of the residents, and there's one track in the morning and it's green, and then the other track is when he or she came back home in the afternoon, evening, and it's already the high levels of air pollution. And also what you can see in the other is also some areas that are quite green, but then areas where there was like wood burning in the evening, right? Like where you could see the exposure changes. So that was giving a lot of information on personal exposure. Next slide. Together, the municipality was also very interested in monitoring around the schools. And here we have also some of the results of monitoring with sensors around the schools, providing also the diurnal patterns and which areas and during which seasons air quality might be higher. Next slide. Our recent work is in one neighborhood in Kristiansand, where there is like the neighborhood is really close by an industry, and there is a reference station monitoring sulfur dioxide, and now we are testing 3 units from Smart Citizen, also integrating sulfur dioxide And this is what you can see in the graphs on the bottom is the comparison between the reference and the sensors. And this is non-treated data. It's raw data. We have not improved or improved and corrected any data, and we can already see that the data is really good, and it might tell us a lot of information. So by using these sensors now, we can also use them in other areas, like in the schools, in this neighborhood, and more spread in the residential areas. Next. And also, this is the area, the industry, the smoke. Those are pictures that the citizens have taken about the industry, and now we have created in the project a data log so that the residents can upload these pictures and also complement the sensors with their observations, and also on the smell, for example, that sometimes we don't have concentrations of sulfur dioxide, but the residents are still affected by the smell. And also organizing workshops with citizens, the municipality, and the industry. And with let Sulborg complement what I have said about these 3 projects. Yes, and the community engagement. It's a lot of engagement, but I think Sulborg can talk more about that.
Yes, thank you, Nelia. I think we go to the next slide, maybe. I will just try to summarize some of our experience from this interesting project we have been doing together with Nilu and Nuria. So first, some key points about collaborating with the city center regarding monitoring with the local sensors. The municipality will then get more air quality data and information about the situation in our municipality. But we also see that it's important for us to know the data quality, of course, from the sensor data. We need to know how we can use it and what the data is good enough regarding use. But as an example, as someone else, others here have been saying and talking about, is using the sensor data to get more information about the wood burning. In Norway, we use or we burn a lot of wood as a heating source, and I think we have underestimated actually how this is affecting the air quality in Kristiansand and in Norway. So this is an example of how we could use sensor data. By using citizen science and collaborating with the citizens with monitoring, it's a cheaper way for the municipality to get more data and information about air quality. It costs a lot for the municipality to install sensors. But of course, then if the municipality is going to lending sensors or something that the citizens is not owns their own sensor, but we are lending them sensors, it's a bit resource intensive to do the recruitment and follow up of the citizens, of course. But if we are doing the lending or send the sensors to the citizens, we have a better control of where the sensors is installed. And we can also guide the citizens where to and how to install the sensor. So maybe we could improve the data, the information data, and we can get more out of the sensor data. But another thing that we think is important for the municipality is that we have this data infrastructure in place that Nilu has and Nuri has helped us with, that we collect all data in one data platform and we store the data so we can use the data in a good way in the future and further use Nuri has. Next slide, please. And we also have some experience with engaging the citizens in citizen science. And we think there has been a great interest in lending sensors and monitoring air pollution with sensors. But it has been a bit more difficult to engage the citizens to join different activities we have been doing during the project, like workshops, webinars, and all kinds of activities. But we, of course, people have attended to the activities, but we would like to have more engagements, of course. But by using this citizen science, we have established a channel for dialogue with the citizens about air pollution that has been very useful and good for the municipality. And by using citizen science and local sensors, it has been a way to increase the citizens' awareness of air pollution, increase their knowledge about air pollution and our knowledge about what the citizens think about it. And it's about building trust, of course. And we also think we have managed to engage and motivate the citizens to develop solutions and local policies together with us, and together find how to reduce air pollution levels in our municipality. So it's been a good thing to do. And finally, I would like to mention also that the engaged is very valuable for the municipality, because they will maybe influence their neighborhoods they are caring a lot about, and also the neighbors, and maybe got some more action that will help us to reduce the air pollution levels in the municipality. Thank you so much.
Thank you so much to both of you. Very exciting developments also in Norway. And with this, I think we conclude the examples, and we will have a rather short feedback session quite over time, but I think it was also very interesting what different partners have presented. And then we will hear from the national and regional levels in the last half an hour. So just perhaps to take 10 minutes, I would primarily like to ask the scientific community present here, especially GRC, EA, and the Sarah from the World Meteorological Organization, perhaps to give some short feedback in terms of how it relates to your current work, like what you think should citizen science and CitiObs do further to strengthen the science policy interface in the context of air quality monitoring, and then perhaps also the different challenges we are facing at the very different levels of government that are also very pronounced in the revised directive. I don't know who would like to start. We have Anne-Marie, Sarah, and Michelle. Just feel free.
Yes, so I guess I can start. I am Anne-Marie Fjærå. I work at Copernicus level within CitiData. We're working on behalf of the EA to see how different data streams, data flows and everything can be secured into a bigger framework. So I was really happy to see so much engagement there today, and see that in the Mentometer, 50% of you are really contributing to this, and very nice presentation. So it's a very, very good work, and of course making this public awareness, it's super important. So I think you're doing a very good job also to meet requirements both on national and international levels. And I can also write a bit in the chat to create some engagement here. But in terms of the Copernicus level, we of course want to help you to secure more long-term funding for contributing to these things. And I saw it a bit also in Solvor's presentation, linking a bit to what are the challenges. What do citizen science projects require in terms of funding on a national level, more international? What can be done by Copernicus to support you to secure the long-term data series? Because if you want uptake into, for example, global model or regional models and things, it's very important to have long-term stable funding. And I would guess also for you as data providers, that is one of the best things that we didn't really touch much up on today. But to trigger some discussion, maybe some recommendations for future meetings, that would be super synchronize at least that from our side. And maybe also the EA can help in some way, the copy and CITO team can help in some way to enable those mechanisms. So that is one thing. And also I'm also curious to learn more about how you can use different APIs to enable the data into national collaboration programs and things like that in the future. But it was very nice to see the showcased projects, I think. Well done.
Thank you very much, Anne-Marie. We will, with our colleagues from the Netherlands, also showcase how to work with the national level in a few minutes. Is there anyone else? Perhaps Michel?
Yeah, I was going to speak. I wanted first to say I'm from a world of metrology. I aspect to what has been presented. But nevertheless, I want to say what's interesting, what I've seen, what I heard, and also some thinking about the presentation. So first, I wanted to say that in the directive, in the new directive, there is still this possibility to decrease the number of official stations by complementing measurement with sensors if the levels are not too high, depending on classification. So still there is this possibility which makes it important to use sensor. But the very negative thing I want to say is that GRC is mainly managing a network of called Aquila, which are the reference laboratory for air pollution in Europe. It's about 40 of those laboratories, which are a very high skill laboratory. Last year, I organized a workshop about the use of sensors. And to my surprise, it appears that the members of Aquila are less and less trusting sensors because of the data quality of sensors. And the result of the workshop was many of those laboratories don't have any more project about deploying low-cost sensors. They still have some project about benchmarking sensors at some reference laboratory. They sometimes still participate into EU-funded projects because they can receive money, so they participate. But there is a great skepticism about the data quality of sensors. And I think the best thing that could happen is a success story with local sensors and data quality. For example, I was thinking about what Nuria was saying about the algorithm of correction of the purple. Please do publish this in journals, because this is the best you can do to re-establish sensors. I think maybe the idea, the negative idea is coming from big hopes in the past from sensors, a step where people have realized there is a concern about data quality, and maybe some solutions are found either at manufacturer level, either at research institution, but user, or let's say user from scientific institutions still have the idea of a few years ago, there is a problem with the data quality of sensors. For example, I was very surprised that Germany says they will not use any more sensors for their legislative purpose monitoring. They will go back to diffusive samplers that we used to use 15 years ago. So we have a problem to solve there, which is re-establish confidence about what you can do with sensors regarding their data quality. Next, DGN and SEN work together to try to establish a protocol of classification of sensors according to their quality. And this classification will help also citizen project, because we have something like sensor from company X is, for example, class 1, which we mean highest possible, highest achievable data quality. So it's just a kind of providing information. But actually, this work we started in 2016, ended in 2021 and 23 with a publication of classification protocol. But actually, no manufacturer are going through those classification, and it's likely because those protocols are published in European SEN as a technical specification, which means guides and not full EN standards. So manufacturers are likely waiting for those technical specifications to be converted into full EN standard, which make it easier to ask for this classification. DGM has funded a project to transform this technical specification in EN, but the deadline is in 72 months, which means it's a long time. By the time, I don't think the situation will change a lot. Maybe of interest for the citizen project is that CEN-TC 264, the working group on sensors, working group 42, is working on a guide for quality assurance, quality control for single sensor and network of sensor, collecting the different documents that exist in Europe and trying to give guidelines. This should be not solved to get. And in fact, what appears in this guide is that co-location of sensor and official reference station is a golden standard, but actually this is too expensive. You cannot do that for all your sensors. There is an impossibility, and what is needed is to develop methods which allow calibration without co-location, because it's just not feasible. In particular, in an area where you don't have reference station, and with David, we are back from a conference in Southeast Asia, where the problem is enormous compared to Europe, because the density of air quality monitoring station compared to the population has maybe a coefficient. I was counting something like 5 times less. Europe should be happy with this something like 5,000 stations in airbase for 450 million inhabitants compared to Southeast Asia, where you have 700 stations for 1.4 billion inhabitants in India. So there are gaps for monitoring, what was said in Europe. Yes, but Europe is still the place in the world where you have the highest number of air quality stations. I understand, and it's true that sensors are interesting for hyperlocal emissions, for wood burning, barbecue. It's true. This is interesting, but it doesn't last for a long time. And there is a problem that was presented in the last presentation, how to be ready for those type of local emission with a network of sensors which would take into consideration this possibility of wood burning. It's really need a lot of preparation, how to avoid to have enormous sensors just to detect wood burning for a few hours. It's a complicated situation. But sensors are there really interesting. In fact, the accuracy of sensors is quite high. Humidity, but this is feasible, and it's what we are seeing. It's quite possible to monitor PM2.5 with sensors, and this is one of the major points for the European Commission. it's much more complicated for NO2 and ozone. And here, there is a room for improvement for gas sensors, NO2 and ozone. Complicated to get a good accuracy on those. I'm looking at my notes. Okay, I think where sensors can be very interesting, and I guess you know it for sure in citizen science, it's the very fast information possibility, either for population information, but I didn't see any presentation about action plans in nearly real time. For example, there are some cities in the world that change their traffic in real time thanks to network of sensors. I don't know if this is already in place in Europe, whether it's feasible, knowing that accuracy is a barrier. How to take a political situation in a situation where you have a lot of measurement uncertainty, it's a complexity. For sure, citizen awareness is an advantage. I was thinking, in fact, open fire, like chimney situation in the Balkan, where population burn very dirty fossil fuel. That's a real advantage. And I'm following, and I think it's really only situation in Europe where you have a real-time data fusion of sensors, model, and AQMS. This is very interesting. It for sure reduces the uncertainty. I'm wondering if there are action plans directly on this project. And I'm maybe thinking about open data, for example, open data treatment, like what was presented in Marseille, with real-time correction of sensors and from AQMS. It would be interesting if this type of algorithm can become published, open data algorithm. That's the question. And in general, joining the platform OpenAQ, I guess you all know OpenAQ is, I think it's a must because you have it at the world level, more or less. And with that, I stop. I'm sorry, I took too much time. Yeah,
No worries, Vishal. Thank you very much. We take at heart the recommendations to publish our success stories and to showcase what is possible. I mean, this is one of the aims also of the project. We are quite a bit over time. I was just, I would like to give perhaps 2 minutes to Sarah, because if there's something to connect also to your work in the international level, and I will post also the resources from the World Meteorological Organization in the meantime, and in 3 minutes we would like to go to our Dutch colleagues to present what they do at national level. Sarah, are you with us?
Yeah, I'm here. Can you hear me?
Yes.
I'm representative of the World Meteorological Organization, that is the United Nations Agency for Climate, Weather, and Water. And there is a specific program inside the organization that is connected with atmospheric composition, and the relevance of local sensors in the international framework is very on the table, because as Michelle mentioned, you did all my points almost, and I will be very quick. There are some parts of the world that we are not having any monitoring site. If you go to OpenAQ, you will see that they start to ingest some local sensors, particularly in Asia, Africa, in South America, Latin America, Caribbean. But it's true that the most important requirement to the manufacturers is to assess the lifetime and the accuracy of these instruments. For the providers, for the people that is managing the networks, it is the operations, meaning the calibration standards that they are fulfilling, and all the maintenance work that they are doing with these instruments. And this is something that is an open discussion also in different communities of researchers that are working with these air sensors, and IGAC is having now a very big community from different places. Because again, Europe, as Michelle well mentioned, is a golden case where you have plenty of reference sensors, reference instruments. Can you do this complementary exercise to look at the city level, where are the sources, where to understand better the activity of the cities? And this is a very appreciated source of information, also to deploy very quickly the instruments is one of the benefits. But for long-term management strategies, still we have the issue that we are not really sure about how reliable are these instruments when you think in years. How is the quality of the information, or how you can replace these instruments in a way that you have a continuous long-term series? Then there are different things that are on the table, and Michelle explained very well. Of course, we are asking the community to put some kind of standards to understand what is the accuracy, latency that we can demand in these potential networks. At the moment, there are some urban scale networks that are working nicely, but when you think in national, regional, international frameworks, these standards means a higher conversation. And the big recommendation now is to assess the uncertainty, because if you want to think in air quality forecasting, you need to assess the uncertainty of this data. And it's true that for PM 2.5, they start to achieve a very good standards in quality. But when you think in PM2, PM10, that is this sea salt, sun and dust, or volcanic, the uncertainty is larger. Then it can be a good exercise for understand extreme events, but still the magnitude of the peaks are quite uncertain. And this is summarized in the report that I hope Masha put in the chat, and it's a big effort of different agencies. It's the effort of 80 researchers and professionals in the field of local sensors, try to understand how we can apply this new technology in different aspects. And citizens science is one of them, awareness, also even personalized health exposure, how a person is exposed. There are many applications, but still we need to discuss broadly what we can demand to these new technologies for the specific applications, and the requirements are quite different depending on the application area. Then I don't want to take more time, because Michel put all the points in his intervention, and this is needed to understand better the quality. At the end, is the quality of this data and how reliable are for different applications.
Thank you very much, Sara, for this contribution. Please also refer to the resources in the chat. We will definitely get back to some of these points. I would like to take the last 20 minutes that we have also to hear from national and regional levels. May ask participants to stick to 5-6 minutes for their presentations, and the other participants, please do not hesitate to use the chat, because the questions that we cannot answer today, we may want to take to a next edition of a policy workshop when we have more robust preliminary results of the workshop, so nothing will get lost. And I will give over to Sjoerd from the Ministry of Water and Infrastructure to tell us about the work they are doing with the transposition of the directive and the Dutch National Clean Air Agreement. Over to you, Sjoerd.
Thank you, Masha. Thank you for the invitation as well. I try to keep it short given the time available. Can you go to the next slide, please? Yeah, I'm Sjoerd. I work for the Dutch Ministry of Infrastructure and Water Management. I want to first guide you through the Clean Air Agreement and then give you some insights in residential wood combustions. Already been said quite some stuff about it, and I want to highlight a bit of the stuff from the citizen science and participation, where I'm responsible for as well, and a few insights in the new Air Quality Directive and how we approach it. Next slide, please. So the Clean Air Agreement. In the Netherlands, we established a Clean Air Agreement, or the CAA, as a voluntary collaboration between the national government, and currently we already have more than 130 local and regional authorities We're still expanding. What makes it special is that we are all focusing on public health improvements, but it also demonstrates that the most real impact can be made without binding legal instruments. We are like all committed to a shared goal, and I think that's something which is quite unique. And it also gives some space and some room for like new experimentation and innovation for areas like, for example, citizen participation. So we all have like a shared recognition that we all want to get a better health quality, and I think that's something that's really unique and really nice. So I would go to the next slide, please. Yeah, I want to highlight wood burning. I think already quite some other people thought about it, spoken about it. For us, it's also something special, and I think what I really want to highlight, since I don't have that much time, is we actually have like a Stokewiser, which is a platform that residents can look up, and they can maybe, if they want to, if there's like unfavorable weather conditions, they can like advise to perhaps not do wood burning or close their windows. So it's something that is quite special, and we also already have Amersfoort and Utrecht is planning to do like public campaigns and bans on pollution peaks. So I think that's already an example that we are like going quite far with it, or at least some cities. So that's something that which is also a bit different than maybe other countries do at this moment. So we really want to raise the awareness, and it's already helping. So next slide, please. So then we have like the citizen science and participation. One of the key pillars in this team, because it's a theme under the CAA, is that we really want to active involve citizens in the air quality policy. And for us, it's also super important to raise awareness among citizens of their own living environment and what their own, how you say it, like their own influence is on the environment as well. So it's not like all the other sources, but also their own sources they are using. And I think it's also a crucial step towards change. So we really want to have like a bottom-up support, bottom-up approach. And that's something that I really stand for, and I really hope that we can get that going a bit more further in the upcoming years. So we really want to get local insights, and that's something that's what already Hester taught a few presentations ago. That's something that's quite hard sometimes, and I really want to get it going through this team. So that's an important thing for our vision. Next slide, please. So what do we really do then? We have really like it's like a tool for education, for engagement, and for better policy outcomes. So we have like a lot of initiatives, and sometimes we can give them also some subsidiary, some money to get going. So we have like temporary exhibitions. We have like car-free zones in particular cities. They want to explore that if there's something possible. And we have the local sensor networks, as Hester just told as well. And it's going to the Samenmeten, or like a Measure Together platform. And that's something that all those initiatives get going to. So that's quite nice. And we also have the Globe. Globe is like the hands-on learning project for students. And it's something also that which is helping them to increase environmental awareness. So in total, like we really want to help and get people to know about what's happening, and we're gonna empower the citizens. So that's something that we really wanna do, and we really want to support it in citizen science and calibrate the national monitoring network. Next slide, please. And I want to also highlight a bit of the new Air Quality Directive. What we have in the Netherlands, we have like a Dutch Environmental and Planning Act, and the act defines the roles and the responsibilities. So we have the national government, like we have like the responsibility for PM2.5, and the local and regional authorities are responsible for the PM10 and then NO2. So what we are trying to do is we are trying to, next to that, get in contact with the other authorities, because we know that other sectors are also like quite important to really coordinate, because we need mobility, housing, agriculture, all those different policies. So To do that, we are really already having talks with them. And next to that, we're already strengthening our national monitoring infrastructure. So we have an installation of 2 new super sites. And I think as well, like, we want to include, like, I would like to include citizen measures in the future, but at this moment, it's not formally part of a national air quality monitoring network, which is used for the compliance and official reporting. So that's something that we are thinking about, but it's not currently happening. So at this moment, our current focus is to really establishing the preparation and collaboration with those other policies. And we are also organizing stakeholders meetings. And in the future, we also want to host like public consultation, and we're going to do that through the internet consultation. That's something that's also like in the planning. So that's the end of my presentation. I hope I kept it short, within 6 minutes.
Yeah, thank you very much, Jort, and also thanks for highlighting the possibilities of working with the new directive. And I think there is also some systemic entry points that can be explored at the regional and the national levels that we will also be reflecting on in our work on the policy side of CitiObs. I wonder if our Polish colleagues are with us, Adrian, Andrzej, and Magdalena. I know that you don't have slides, but perhaps you could also share a few insights in about 5 minutes on how you do air quality assessment in Poland and also how you work with the different regions. We have seen, of course, that there are some hotspots in Poland and some regions that require particular attention. And perhaps you could give us some feedback and also regarding of what you heard from the rest of the meeting just before.
Yes. Good morning, everyone. My name is Adrian Hoppa. Thank you for the opportunity to participate in the workshop. I'm today with colleagues from the Chief Inspectorate of Environmental Protection, and I would like to give a brief overview of the activities carried out by the Chief Inspectorate of Environmental Protection on the annual assessment of air quality and the changes that the new Air Quality Directive brings in this area. So each year our institution carries out the duty to assess air quality, the obligation to carry out an annual assessment of air quality in zones results from the provisions of EU law transposed into national law. This assessment is carried out at the level of 46 zones, including 12 agglomerations, 80 cities, and 16 zones, representing the rest of the voivodeship. The classification of zones in the annual assessment is carried out separately for 2 groups of criteria. Those determined to protect human health and those determined for the purpose of protecting plants. And the purpose of the assessment is to classify zones according to specific criteria to obtain information on the spatial distribution of pollutant concentrations in the area of the zone, to indicate the reasons for the presence of above normal concentration of pollutants. If simultaneous measurements of a given substance by reference and non-reference methods are carried out at the single station, the annual air quality assessment takes the result of measurements made by the reference method. For example, for PM10 and PM2.5 by the manual method. And currently, in addition to air quality measurements at the monitoring stations, modeling is playing an increasingly important role in the assessment system. Modeling is an integral part of annual air quality assessments. The data from modeling helps fill the gaps in the country's coverage of the measurement system by allowing assessment of areas where there are no functioning monitoring stations. And to calculate pollutant concentrations near the ground surface, the latest assessment used the GEM AQ air quality model, which was developed based on the global environmental multi-scale numerical weather prediction model. In the coming years, according to the requirements of the new directive, we plan to adapt our monitoring network system to the specified requirements. Implementation of the directive involves an increase in measurement stations, mainly at hotspot locations. Due to the time needed to locate and launch all traffic stations, it's planned to start testing nitrogen dioxide concentrations by passive samplers in the largest cities in 2026. The directive also requires the launch of 6 superstations in Poland, 3 urban background and 3 regional background, and also additional 7 ultra-fine particles measurement sites at hotspot stations. By implementing a new approach, combining measurements together with modeling, our air quality assessment will be more precise and in line with the latest EU standards. This is an important step in improving Poland's air quality and reducing emissions in the coming years. Thank you for your attention.
Thank you very much, Adrian, of giving us the insights also from happening in Poland. We also hope that you will stay in our community, and because you work with so many regions and cities who are also, by the way, present here today. We have participants from some larger cities in Poland with us, and also a Polish consortium partner. And as a very last presentation, but nonetheless very interesting contribution from Catalonia, I would like to give the word to Eva from the General Directorate of Climate Change and Environmental Quality to give us a very brief overview how Catalonia is working on the approach to citizen science and communities. And here I think this is a very important aspect for the revised air quality directive when it comes to access to information and transparency. Thank you very much, Eva, for being here with us, and apologies for the time.
Thank you very much. Good morning, everyone. First of all, I would like to thank you for inviting me to participate in this workshop. And also I would like to thank everyone for attending. Today I'm going to explain Catalonia's strategy for enhancing air quality awareness. Our strategy is based in 2 ideas. First, providing clear and accessible information about air quality, and second, carrying out activities in order to involve our communities. Our goal is to spread knowledge about air quality and to grow an air quality community. Next slide, please. Okay, first of all, I'm going to explain how we inform about air quality. We inform about air quality by 3 ways, okay? First of all, providing air quality data. We provide real-time air quality data and forecasting through Bolsa que respiras. That means, do you know what are you breathing? A platform is a web platform, and IRECAT mobile app. These platforms allow the citizens to check the air quality in their area according to the information of our monitoring station network of our region, across the region. And also we inform about if the air quality is good, according to the European and Spanish Air Quality Index. We also provide a forecast and some extra information, additional information about the monitoring stations, relevant information and about the situation of air quality. In addition, we provide also validated historical and current year data that are available for download in the Open Data Portal. This is very useful for citizens, for companies, and for researchers if they want to work in new projects of air quality. In addition, where the air quality levels are high, a short-term plan action is activated, and we inform to the public about the levels. Last year, we adopted a new short-term action plan. The territorial scope of this short-term action plan is the whole territory of Catalonia and considers 5 pollutants: sulfur dioxide, nitrogen dioxide, PM10, PM2.5, ozone, and also benzene. For us, is a very important tool to enhance air quality awareness. We inform the public, the local authorities, and the competent authorities to reduce air pollution, provide information of the affected area, pollutant levels, health recommendations, and measures. When we activate the short-term action plan because of the high air quality levels, our website is the most visited of the all ministry. And I think that point is interesting because I think this kind of episodes raise the awareness about air pollution. And to finish, every year we publish the annual report of air quality assessment. Everyone can check the evolution of air quality in our region and also can check the challenges we still face. Next slide, please. Okay, besides providing information, we carry out activities and projects to raise awareness and involve people. Well, what we have done, we have implemented an educational program on air quality for primary, secondary, and high school students with over 100 visits per year. This activity is divided into parts. One part, we organize experiments with students to explain the phenomenology of air pollution and engage them to participate and involve them in the results of these experiments. And after that, we visit a monitoring station. We also have been collaborated with the European projects, specifically in the Capture project and Citizens project. Last year, for example, we designed an activity that we call Detectives del Aire. It means air quality detectives. This science activity, city science activity, targeted for families and citizens. And we empower the families and citizens by measuring air quality and also investigating what are the origins of air pollution, and they have to propose actions to improve air quality. For instance, we organized this activity at the Barcelona Science Festival that took place last May, and in an event organized by ES Global as a part of the BEAST project. That is a project that investigates the effects, the air pollution effects on health for pregnant and children. Next slide, please. Also, twice daily, regional TV, news, and radio broadcasts provide updated information about on air quality and other situations about high pollution episodes. And there is another project that we have just implemented a few months ago that at the entrance of the regional administration building, a screen displays real-time air quality data from the most representative monitoring site, depending on where is the building located. What else? Ongoing activities. We have a collaboration in the RIS-3CAT project together with IS Global and the Ministry of Education of the Government of Catalonia. The objective is engage young people in addressing the social and environmental challenges that we are facing. We are designing some kind of activities, attractive activities to engage them and take part of the problem. And to finish, we are working on an agreement with the Hospital Sant Joan de Déu, that is the pediatric hospital of reference in Barcelona, for data exchange and dissemination of air quality information in healthcare centers. And just to finish, to sum up, I would like to say that to enhance air quality awareness, we are working. Our strategy is based on informing the public about air quality and organizing and participating in activities to engage the community. In my opinion, this kind of activities, this whole project, not only enhance air quality awareness, but also foster trust and acceptance of new measures. When citizens are informed and involved, they are more likely to accept new policies aimed at reducing emissions. And that's all from my part. Thank you very much. I've not written down my email. I can share it in the chat.
Thank you very much, Eva. Very interesting. Feel free to share your contact details. Unfortunately, we have run a little bit out of time because the discussions, also the presentations were very interesting and very engaging. But of course, we take some important lessons home with us. Especially when it also comes to further advancing the success stories of citizen science work, also continue working on the data quality. And we will also have a new financial framework with a continuation of the Horizon program, where I think it is sensible to make also some suggestions how to invest in financial schemes for citizens initiatives, data spaces, and ideas that were mentioned here today. Thank you very, very much to all the participants, to our cities from Poland, from the Netherlands, to the scientific community, GRC, WMO, EIA, the European Commission, and our consortium partners. We will send you all the presentations in a PDF format to all the participants, which will also have the contact details of the respective people who have intervened. So if you need to get in touch, if we need to further exchange, we will certainly have the opportunity to do so. And we also look forward to perhaps organizing another workshop, perhaps face-to-face, in the near future. Thank you very much for today, and have a very, very nice weekend.
Thank you
very much.
Thank you. Goodbye.
Thank you.
Thank you. Bye.
Thank you, Maxa.
Bye-bye.
Bye.